we will graph in Vertex Form, and we will do a lot of the same processes that we did yesterday, where we use the vertex. I don't want you to use a table of values if you can get away with it. So I have a couple of options for you. So here's what I have for steps 1, 2, and 3. Now what I want to change about 1, 2, and 3, first of all, you're just going to write the vertex. Then I'm going to identify and graph the vertex and the axis of symmetry. But for number 3, something else you can do is to find the Y-intercept by making x equals 0, then solve for y. Sometimes our graphs have a Y-intercept that's decent. Sometimes our graphs don't. Okay? Yeah.
I don't think we have the same steps as you.
I know. So, first of all, it's not in Vertex Form. We need to put it in Vertex Form. And how do we do that? Okay, negative b over 2a. By the way, a equals negative 2. Okay? Negative b over 2a. 16 over negative 4. X equals negative 4. Halfway done with my vertex. So just like last night's homework, right? Then I have to find y. Plug it in, plug it in. Instead of x in my standard form, put negative 4. And it's a lot of math, actually. Negative 2 times 16 plus 64 minus 31. Big numbers. Okay. Negative 32 plus 64 minus 31. What is negative 32 plus 64? Wow. All that work just for 1. Frustrating, yeah? Math can be that way sometimes. My vertex is negative 4, 1. So in blue, I'm going to write my vertex form. Y equals A, remember A was negative 2 from before and from the original, x plus 4 squared plus 1. Vertex form. Second thing I do is I'm going to do some graphing. I'm going to graph my vertex and I'm going to graph my axis of symmetry. My vertex is negative 4, 1. My axis of symmetry just runs straight through this. This is a dotted line going through the middle. So I can either find the y-intercept. You can do what I have up there and make a little small table of values. So now if I were, let's talk about both ways. If I were to make a table of values, I'm going to have to find what ordered pairs are over here on the left of my vertex? What ordered pairs are on the right of my vertex? So you can plug in to your equation like x equals -5 or x equals -6 and plug it in there and see what you get. Or you could do plug in x equals like 2 or 3 and find out what happens. Is my parabola going to be upward facing or downward facing?
Downward.
Downward because of that. So that's something you need to know. I also put in red here that I can find the y-intercept, which will kind of tell me the shape of my graph. So I'm going to first do, because I have like no space, I don't know if you guys have more space than I do, I'm going to first do in red, I'm going to find the y-intercept and see if that works. Y-intercept means I'm plugging in 0 for x. Let's do it in purple so that it's all like separated. Y equals -2, 0 squared, minus 16 times 0, minus 31. Okay, my y-intercept is 0 minus 0, -31. Can we graph 31? No, way too far down there. It's way down here. Y-axis, -31. We don't have room. So, I need to make a small table of values. Sometimes this y-axis trick will work and sometimes it won't. I mean, I have a giant 16 and 31. These numbers are big. So, now I have to make a small table of values in like no space that I have. I'm going to have to zoom in. Okay, ready? What were the numbers that I said I would have to pick to plug in on like the left side or the right side of my vertex? I need like a little bit of the parabola on the left side, and I need a little bit of parabola on the right side. What numbers should I plug in to find the left side of my parabola? -3, no. -3 is going to be the right side of my parabola. -5 or -6. Okay, so let's do one of those. So I'm going to plug in, let's do -6. In for x. Okay, so y equals -2 times 36. Ooh, 16 times 6. -96 minus 31. -72 minus 96 minus 31. This is my table of values. I'm doing -6. Where's positive? I would love for anything to be positive. Oh, thank goodness. -72 plus 96. 14. Six, 7, 17. -6, -17.
14?
What?
Oh yeah, the difference of 72.
I think 72 and 96, the difference is 14. I feel confident in that.
It's 24. Because 96 and it's 24.
82 would be 14. Wow, I'm really just... How do I make it erase? Oh, what? Teacher fail right now. Teacher fail. 24 minus 31. -7. Negative 6 comma negative 7. Now let's go back, and here's my problem. I have to make sure that my work is exactly on negative 4 comma 1. Okay. So, negative 6 comma negative 7. Negative 4, negative 5, negative 6, negative 7. 1, 2, 3, 4, 5, 6, 7. Let's do blue, because we're graphing in blue. Right? So, I only have to do one table of values entry, because now I've got this. What's going to happen, guys? Where's my next order pair going to hit? Because it's symmetrical. It's like a mirror. Whatever's on one side's on the other. So where will my other point hit? On the right. Negative 2, negative 7. Your axis of symmetry cuts your parabola in half. That and that are symmetrical. Wow. 11 minutes later. Yes?
Yeah.
This is Vertex Form.
Can't we plug it into there instead of plugging it into that?
Yeah.
So we can-
You can plug in your X thing, whatever you pick for X, into Vertex Form too. Do that for the next one. And look at these easy numbers. Thank goodness, right? Okay. Did I just do a good job of showing you what not to do?
Yes.
Okay. First, change this to Vertex Form. My A is 1. Oh my gosh, this is going to be so good. Wow. Stop. How do I get rid of that? I don't want that there. A equals 1. This is like a parent function 1, which means whatever happens from my vertex, I go like over 1, up 1. Over 2, up 4. Remember that? So this is nice. Here we go. Negative b over 2a. Right? Negative 3. I'm halfway done with my vertex. Negative 3 comma something. Now plug in negative 3 into your standard form to find y. Negative 3 squared plus 6 times negative 3 plus 7. So now I'm going to solve for y to find the rest of my vertex. 9 minus 18 plus 7. Ah! Did you get your vertex? Negative 2?
No.
Okay. Graph your, let me make this a little bit larger for you. Oh, man. Okay. Negative 3, negative 2. Okay. Axis of symmetry, it's a line. Doot, 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 doot. Now, since this has an A that equals 1, my graph is going to be like a parent function graph, where it's just the typical curve. The typical curve means that I'm going to have from the vertex over 1 each way. Oh, is my graph upward facing or downward facing? Upward. Over 1 both sides, up 1 both sides. So go ahead and do that. Over 2 both sides, up 4 both sides. I didn't even have to find my Y-intercept. I didn't even have to make a table of values because this was so nice in parent function because my A was 1. This screen looks really nice compared to last screen. Okay. Okay. Now, this is going to be a downward facing parabola because it starts with a -2. So, go for it. You work while I work.
Okay.
And then you guys can tell me my mistakes because I'm just like blowing it today. Wow. Okay. I know everybody has mess ups, right? So, x equals -b over 2a. I'm found the first number in my vertex. I am now going to use this -2, and I'm going to plug it into my standard form. Okay? No mistakes this time. Don't be copying straight from me. You need to do it on your own and then look at your answer and see if I got what you got. Otherwise, you're just copying and you're not learning anything. Okay. Do you agree that our vertex is -2, 1?
Yes.
Okay, let's do that. -2, 1. My axis of symmetry goes straight through, down, 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 down. My graph is actually downward facing because it's a -2. Now this is the time where you can just plug in, oh, first let's write our vertex form. My goodness, my goodness. A x plus 2 squared plus 1. I'm doing adding and subtracting and plugging in.
Why is math so hard?
Oh, I understand.
I don't want to make it hard. Number 1 and number 2 are much easier. You are changing it to vertex form. Now I can either do one of two things. I can make a little table of values and find out how is the left side of the parabola going to look by plugging in like -3 or -4 into vertex form, or plugging in 1 or 0 to find the other side. Or I can find the Y-intercept, and maybe the Y-intercept will not be some crazy number that's really high. Your sure bet is to like pick a number on either side of the parabola and then plug it in for x. What number would you like to plug in for x? 0. Because that's going to be... So I'm going to do it in purple. Plug in 0 into x. Okay? So I've got -2 times 2 squared plus 1. -2 times 4. 2 squared is 4. Plus 1. -8 plus 1. Y-intercept will be -7. So here's a point on my graph, 0, -7. I found that by plugging 0 in for x. Yep.
Why'd you pick 0?
I picked 0 because I have to pick some point on the left side, like -3, -4, -5, -6, to see where it hits, how the curve goes. I chose to pick something on the right side because the graph's going to have to go down this way, the graph's going to have to go down this way. So it's going to have to hit on 0 somewhere, and 0 is an easy number to plug in. That's why we picked 0. You could have picked -5 to plug in for x. You could have picked -1 or +1. 0 is easy. We picked 0. 0, -7. Okay. There's half of my parabola. I'm going to start it. Where's it going to hit now? If it's a mirror image of itself, where will my parabola hit on the other side? Look at the blue line. Just go over from the blue line. How many spaces is it from this blue line? So it's going to go 2 here. And I drew such a bad parabola. So basically what I'm doing is this. I'm picking my vertex. And then I picked something on the other side of it. And I also got -4, -7. So this is what I did. If you need it in this format, I can do that. I was just running out of room, and it's like, space is so hard to come by on this worksheet. I don't want to do 3, but I do want to do 4. I'm going to talk about a fraction. Okay, let me press pause for a second. So this is fraction means what? That my parabola is going to be fat. So keep that in mind. A equals -1/2. Okay. We're changing it into vertex form right now. Don't just copy what I'm writing. Do it one step ahead of me. Yes, sir. X equals -b over 2 times -1/2. It's fine. 2 can be cut in half. +4 over -1. Half of 2. Okay, my x of my vertex is -4. Now I need to find my y. So how I'm going to find my y is I'm going to do plug in -4 into your standard form. Y equals -1/2. X, instead of x, I'm going to put -4. Minus 4 times -4 plus 1. Okay, -1/2 times 16 plus 16 plus 1. So I'm just like doing math, you know, order of operations. Half of 16, -8. Don't stop. Okay. My vertex is -4, 9. Think. I left this graph empty because you need to be the ones to decide how am I going to draw my x-axis and my y-axis so I can fit a -4, 9. Will it look like this? Will it look like this, or this, or this? You have so many options on how to make your x and y-axis. I need to go -4 and then up 9. So I need a big second quadrant, we'll say. This is how this looks. Y-axis, x-axis. Okay? So, graph it. -4 up 9. way high. Is my parabola going upward facing or downward facing?
It's gonna face down.
It's going to face down. Now, I promised you that I would make your life easier this time with my finding the rest of the parabola. So I'm going to stick to that. Remember how we always did 5? -4, comma 9. Your axis of symmetry, I'll make it like purple. Yep, let's write vertex form. Y equals -1/2 x plus 4 squared plus 9. There's vertex form. Okay, here's my vertex. Here's my purple dotted axis of symmetry. I need to find either a point on the left of my vertex or a point on the right. And I only need to pick one number because then I mirror it. What number would you like to choose on the right? -3, -2, -1, 0, 1, 2, or -5, -6, -7, -8. What would you like to plug in for x? There's number one that's really easy. -2 is like not as easy as another number. Zero.
I said that.
Pick where it's going to hit. So I'm going to plug in on my x. I will put a 0. It's going to be like way down here. So plug it in, plug it in. -1/2 times 0 squared -4 times 0 plus 1. What's it going to be? 0 minus 0 plus 1. 0, comma 1. Okay, now, here's what I got. I'm doing my best. Oh my gosh. Now. Okay. Go from your axis of symmetry. How many spaces over did I go to the right? Actually, it needs to be right here. 1, 2, 3, 4.
4.
So I'm going to go for the other direction. 1, 2, 3, 4. It has to be symmetrical. It's like a mirror. Whatever's on one side is on the other side. Finish your parabola. What, the bell's gonna ring?
Yeah, it is.
So, woo! That's a lot of work. Let's talk about what my expectation is for you. You're pooped.